I'll just briefly introduce the people. We have Don on the very left. He's a moderator for this one. We have Arian on second. We have Julien, third. Martin, fourth. And John on the right end. So I'll give it up to Don. Take the stage.
Supply chain security. This is going to be a concise talk. We don't have much time. There's a lot to discuss, a lot to share, so we're not going to go into much detail. Please be concise with your responses to my questions. So, what is supply chain security? Who wants to?
I mean, that's a good question, Don. To me, supply chain security is about this, about the fact that systematically computer scientists, never mind, people working with computers are kind of bad at tracking where things come from, and that led to a range of security issues, and so it's become kind of a hot topic to talk about, where people worry about things like what are the ingredients that go into my specific piece of software that I'm running, and am I vulnerable to this specific security vulnerability? Which version of this one library am I running? Things like that, to solve their practical issue of, oh no, what if someone doesn't what if not my program is vulnerable to some exploit, but one of my dependencies is?
So it's being able to answer a whole bunch of questions about the stack that I'm using, and to be able to have confidence in the answers to these questions.
Yes, but does anyone want to jump in? And because I think it's a bit incomplete still, because it's not just answering the questions, but also making sure that it's not just about answering the questions. It's about building things in a way that it has somehow defined properties, and that you know what. Yeah, I think. Never mind.
Okay. I'm too young to speak about this from experience, but my read of the sort of history of the industry is, for many years, people had really a hard time reusing any code at all. And every job you went to, they had their own sort of palace of their own abstractions and own internal infrastructure, and you went to a different job and it was all completely different. And it was that way for many years, many decades even. And then one day the pendulum completely swung the opposite, and it went from having not enough other code from elsewhere to, holy moly, I have all this code that I didn't write that it has nothing to do with this company, and it was this big 180 culture shock, and so this shift kind of fixed a bunch of problems only to introduce a bunch of new problems that caught everyone off guard.
So we're grateful for open source, but now we have come unprepared. We are flooded with this supply chain trust issue.
Yes.
So what are the deficiencies in our context?
I feel like a lot of people don't even know what they're depending on, right? What are the dependencies I'm actually using? How many projects am I depending on? How often are they updating? How do we keep up with that? It's a lot, right? It's very, very difficult. So if you look at, I was looking at Vault, which is this security product, right, for storing secrets, and their UI has it had 30,000 transitive dependencies. And it's this is the interface where I'm putting my secrets in. Who am I sharing my secrets with? And it's it's a hard question. So I think, that is, I think, the start. And I feel like Nix is kind of uniquely positioned because we are so precise, right? We have the complete answer, but then people get overwhelmed about the complete answer is too honest. And they're like, oh, what is all this? Why do I have 100,000 derivations in my bootstrap chain? So, yeah. So that's the other side. Is like the UX of all of this. I think is also very important.
Yeah. And I think like one of the problem also is that the practices in software security for years are focused on how to write code that doesn't have vulnerabilities, and in the last few years we've been seeing a lot of attacks targeting not the software itself but everything that comes around, and it's a whole new class of attacks with all new clever tricks, and we are unprepared for it because just we were not taking care of this part of the security practices before, and so now we have to build up effective defenses against this kind of attacks.
And this might also be about, okay, who contributes to the project and what are our processes and what are our workflows and things like that, because that might also be part of the issue, right? I wanted to say that before, but I kind of got lost, so yeah.
So what progress, Nix, in the context of Nix, why do, sounds like we have an opportunity to leverage Nix. How can Nix empower solving these questions, answering these questions, providing solutions?
Well, the hope and dream in many cases, also the reality is, whereas with other systems you can kind of know, or you can write down what you think ought to be true, or really even more than that, like you ask someone once and it was true. With Nix, we actually know where all the source code came from, where all the tools at build time came from, where the tools of the build time for the tools we use, the transitive build time came from, and we can kind of trace the whole rabbit hole to every dead end and actually answer this question once and for all. So that's the good side. The bad side, as Arian said, is the answer is very daunting and way more information than anyone thought they were getting into with this sort of thing.
Yeah, like conventional tools and people like in other ecosystems, they have to they have some way how they build software, and then they run after that way of building software and try to figure out, okay, so this artifact falls out of here, and then where does it go? And there's a lot of effort spent basically trying to retrace those steps and making them transparent. But you have to do that in every kind of context, every ecosystem. You have to make sure that you're not missing anything, which is really hard. And we do that by construction, as John mentioned. It's like a really different approach to this problem, but one that seems kind of like principled and like a promising way of handling this issue. And I think that's kind of the promise that we have in front of us, but we're not sure if we're living up to it yet.
I think one thing that is really interesting is because of the way Nix was designed, we have a lot of good properties that comes for free. Like you both said, knowing the transitive dependency of build time or runtime dependency of a program is something extremely valuable. But what can we do next? And the difficult problem for me is the social problem. We are all aware that we have all those things for free, and it's cool, but 99% of the software engineers, they don't use Nix, they don't know what is Nix, and they don't want to know what is Nix if you come to say to them, Nix is so much better than what you use for security. So we need to convince them first, and we need to build tools that can enable those good security features without the rest of the software community knowing that they are using them. We need to be the backbone for software supply chain security without the rest of the software community having to learn or know what Nix is.
It sounds like Nix gives us a lot already. It almost sounds as if the problem is solved. But what is missing?
Well, I think one way to look at that is people say, well, Nix is very different. And if I'm going to learn something that's very different, it better be absolutely as tippy-top good as you promised. I want there to be no catch at the end of my spending 100 hours learning the new thing. And unfortunately, if that's the claim, and maybe this is a bar that's too high and we shouldn't get distracted, but if that is the bar we have to meet, there are some catches. The input addressing we do today for build artifacts, it doesn't tell you as much as you'd like. It can conflate things that are different and are different from that very transitive build dependencies perspective we're so proud of. So that sort of undermines our claim of greatness. That's my favorite example, or least favorite example. The one that I think about the most. There's
fixed output derivations are kind of a problem, I think, also.
Yeah, fixed output ones there are, thank you. Our caching scheme there, it's like very useful for some things, but then like a little bit too loosey-goosey for other use cases, and how can we sort of have the best of both worlds there and have the policy we want when we want it and not the wrong policy at the wrong time. That's a very similar problem to the content addressing versus input addressing one. Yeah, those are two good examples.
Yeah, I think like practically speaking, as a company or a user, for example, of the Nix cache, and you decide to, I'm going to build Nginx, and instead we fetch it from cachenix.org, right? That's why we love Nix. But then you want to answer questions like, what derivation was actually used to produce this output? And there's actually a funny fact that this mapping is not one-to-one. The same output hash can be produced by a multitude of derivations because of fixed output derivations. So, and we don't really keep track of that info right now. Like, I cannot answer the question from just looking at the cache. Hey, when did Hydra build this version of Nginx? On which builder was it? Was that builder running an up-to-date version of Linux when it's built? Like, all these kind of like after-the-fact questions of like, say we do get a compromise or we do ship something that is like not good. How do we start tracking all these things of like, how did we produce these software? I think we can make a lot more improvements like than we have today. And like these questions are hard to answer.
And I think sometimes we're even losing security people on that. If they like take Nix seriously and say, okay, let's see if this solves a specific problem in my organization, and they analyze this stuff and they come across these issues of, well, technically most of the time this one field should tell you the derivation that produced this output, but then sometimes it's wrong, then you stop trusting the tool, right? So that's bad for us, because it just means the tool we're working on and that we're working with is bad in that way, right? Because like that's one, I think that's a consequence of how fixed output derivations work, right?
Yes.
Yeah. So the deriver field, right?
Yeah, and I also remembered the one I was trying to think of there, which is even without fixed outputs, just sort of mere non-determinism, you have a similar problem. Most of us, I think, are of the correct opinion that Nix is really great for reproducibility, but there's definitely people out there on the internet that say, no, Nix, its caching hides the non-reproducibility that exists. If you have some GCC build that makes a new GCC every time, the fact that you have all these cache hits means you'll never know that, and it's not solving the problem but hiding the problem. That's sort of I think the Gentoo people or something were saying that, though I shouldn't name names when I'm not sure. And that's a similar thing to FODs. Like we want to cache really hard when in certain cases, but we also want to sort of fall back and verify that things, if repeated, do what we expect in other cases. And managing that sort of multitude of needs is tricky today.
What are some of the progress that has been made recently?
Well, I think Martin and I have both been thinking a lot about how content addressing build artifacts can sort of put these problems to rest, and that the ultimate issues here, well, there's the FOD stuff too, but the sort of most complex issue is the input addressing, and if we can switch to content addressing everything, not just the ultimate sources, but also the intermediate artifacts, we can have a much greater visibility into these issues, and when we have determinism and when we have non-determinism, and track this stuff much more robustly in the sort of perfect way that the idea of Nix is promising us.
Maybe a way to kind of illustrate that problem that you're talking about, Right now, so I'm working on a specific signature scheme, right? That is kind of that I'm proposing as, hey, would it be cool if Nix like incorporated this? So I'm trying to get this upstreamed. But like, so I'm thinking about signatures basically, right? And how this works right now in Nix is you have some builder and it builds an output and it associates like the hashes of all of the like leaves in the dependency tree, like the outermost thing in the dependency tree with the final output. So if you think about the graph, there's like a huge gap in between, like all of the intermediary steps. You don't really know from the signature what the specific identity of that was. You don't know the content hash of the specific version of GCC that factored into building Firefox, for example. And this is just how, like somehow it's just a consequence of how the addressing of the store works. And coincidentally, we started out with input addressing because it's much easier to implement. And if you start content addressing, coincidentally, you can model this much better because then if you have like, for example, the version of Firefox you just built, if it depends on GCC, since the store is content addressed now, it depends exactly on a specific version of GCC by a specific content hash and not by like the hash that's based on the recipe that produced it. And since this is more specific, you kind of get rid of this gap. And that's like the magic thing about changing the addressing scheme and what it does for supply chain security. And like, and I think this is really an innovative, cool thing because everywhere else, if you talk about, oh, I'm gonna build some software and then I'm gonna give it to somebody, ship it to somebody in some way, you always assume that you have to trust the build environment that those people that hand this software to you produced it, right? And like if we're really strict and pedantic in Nix, we can kind of get away from that like as far as possible by saying, well, if they give us something through Nix, we know what the intermediary inputs are, so we just have to trust them with that one build step. They maybe be able to offer some proof about how they performed that step, but like we don't take on their trust relationships anymore, which is like really more than anyone else can do, I think, in the supply chain security space, right?
And that is a proposal for a new signature.
That's like So I had this talk last year about these kind of issues. It was called like rebuilding builders instead of trusting trust. And I had like analyzed these things in terms of trust. And then after that talk, I talked to a bunch of people, a lot of them on stage here now. And that was a very interesting, motivating experience. And I then worked on basically proposing something more specific. And this is not ready yet for users, but it's like a work in progress thing that you can look at online and you could contribute. There's a bunch of stuff that's like still.
Where can it be found?
Like my GitHub username is mschweig. This is like the first letter of my first name and then like the beginning of my last name. And the project is called Loud. You can look it up and like come talk to me about it. There's really a bunch of open issues. So I'd be happy to talk to you about, help you contribute whatever you're interested in.
John, what have you been contributing to?
I would say sort of similar to that. I and others back in 2020 did the first big push in Nix as it's been merged upstream of implementing constant addressing derivations. And we have many passing tests and things, but there's some not nice bits in the design that I've always wanted to revise, and other sort of bits of incompleteness. And a lot of that has just sort of stayed that way ever since 2020. I think leaving us in a state where much of the community doesn't really know what the status of the experimental feature is. It seems like yet another promising new thing that's not quite over the finish line. I'm happy to say right now I'm in a position to spend a bunch of time finally fixing these issues and getting to the bottom of things. And the plan is, as part of that work, that we'll have RFCs detailing sort of what the final roadmap ought to be, and like what really takes us to the finish line here. And I'm looking forward to working with Martin on some of that stuff, so we make sure we have the perspective of multiple implementations going into what I hope is like feature specification the whole community can agree on.
Yeah, that's great, thank you. And I think also it's kind of an invitation also, right? If there's an RFC process, it will mean that we're looking for feedback on these things, right? So
yeah, absolutely.
This could be your calling too.
Yes.
Take a look
definitely.
at that.
Julien.
Yeah, so Martin has talked about signature. There is another field that I am interested in is build reproducibility. And I think there was a lot of effort put into build reproducibility in the last years. Build reproducibility is when you get the same thing by building the same software twice, bit by bit identical. And it's super important because currently when you use the cache to download a binary, you are like trusting that the cache is giving you the right thing. You don't have any confidence in that. You have to trust that the builders are trustworthy and that no one controls the cache and can give you can put a malicious binary in the cache that you download, this kind of stuff. And so it means that you have to trust a central party, which is something that you want to avoid if possible in software supply chain security. And one way to go about that is if the software you want to download is reproducible bit by bit, it means that you could rebuild it yourself and obtain the same thing as the cache. Or you could also ask several other third parties, like companies you trust, to rebuild it, and if they all obtain the same thing, you know that you can trust what the cache is giving you because other actors have obtained the same thing. So that's why build reproducibility is important and could have a big impact. I did a paper, so I'm a PhD student, I did a paper where I looked at the evolution of the number of packages that we have that are reproducible over the last 6 years, and we've been from about 60% packages reproducible to now about 90%. So we have almost all our packages are reproducible, which is insane because, like, you know the size of the package set. So it's a great achievement, and it means that first some good work have been done here, and some good work could be done in the future to create some model of decentralized cache. So instead of having one central cache that we all have to trust, and that which is not an ideal situation, we could have a lot of different actors building stuff and agreeing on the hash that they produce, and then when a sufficient number of actors agree on the hash of the thing you want to download, you know that you can trust them. So that's also a piece of work in the NixOS community where there is activity and where there is, I think, great promise for the future.
And all of these things also kind of like interact, right? So it's a lot of us are working on different things, but somehow there's always like a point where they, like not everything, but some things, oh yeah, and this links up somewhere. If, for example, if you have a good signature scheme, you could say, oh, when I look at reproducibility, I do it on the basis of those signatures, for example. But there's also like unrelated issues, like for example, the CLI for rebuilding, I think is kind of bad.
Oh yeah, it's not ideal.
Yeah, I wanted to ask you about that because you probably have like the most large-scale experience with your work.
Well, not get too long in this topic, but for my experiments in my paper, we had to patch Nix to make it behave better with the rebuild flag.
Okay.
Because the rebuild flag doesn't keep all the non-reproducible output, it stops at the first one that is bad, so that wasn't good for our experiments. But yeah, there could be improvements in that regard. I think Lix had done something in this area, but I don't know.
Okay.
In your work, Julien, with distributed cache, is that public?
Yeah, so there is two sides of this work. So there is some academic work. So I've written this paper where I look at some revision of the past 6 years and look at the number of non-reproducible packages, why they are non-reproducible, that stuff. All of this is published and open access if you're interested to read. And the name of the article is something like, does functional package management enable reproducible builds at scale? Yes, that's the name of the paper if you're interested. And there is the community side of the work, which is with Rabouf, who is another Nix package contributor. We are building a database of build results. So essentially, we are plugging in after your Nix build in a post-build book to report the results of your build, and we are creating a big database where you can query the result, like the build output of some of the packages that we have. And the idea is that we can now have a better Nix package monitoring for reproducibility, because for now there is not really a big monitoring. There is monitoring of the reproducibility of the ISO images, which is only a few thousand packages, but we want to have a monitoring on the whole package set, which is hard because it's 100,000 packages. It's already hard to build it once. It's also hard to build it 2 times. That's why we want to create some kind of shared workload where everyone can install the software and start reporting on the build that they do. And at the end, we have some nice reporting of the packages that are reproducible, not reproducible, and what is the diversity of output that we obtain from a single package, for example.
What is that work called?
It's named Lila, so it's being developed. We have a staging instance, but we aim to have something ready for public consumption at the end of the year.
Arian.
Yeah, so I've mostly been trying to look at what other ecosystems are doing better than us, and one of the things we've not been very good at is like we have just one signing key which we sign all our builds with, right? And they're not being signed by the builders, they're being signed by the Hydra coordinator. And we haven't rotated this key in like, I don't know, 15 years.
Yeah.
So how do we convince people I'm not saying that the key is untrustworthy, but I'm saying how do you convince that it's trustworthy, right? And other package ecosystems have all been kind of flocking around this standard called SIG-Store. So PyPy has now started using it, Cargo, NPM, because they've had all these supply chain attacks, and they're like, they upload binary artifacts to NPM and to PyPy. You have wheels, and for Cargo, like the source code gets published, and they have a signature scheme that is based on like short-lived certificates on a public ledger with like timestamping when it was built, so that you can like after the fact like verify that it was signed with this temporary key. And I'm very interested how we can start integrating that into Nix. And I built a little prototype called Nix Attest, which is also a Nix post-build hook, and just records all the builds that I do into this SIG-Store public ledger using temporary public keys. So, and this is like a nice hack that we're all doing, I think.
So we have John working on Nix, and all the 3 of us doing something with post-build hooks.
Yes, to avoid the dependency on John. Yes, but yeah, I think that's like very interesting, right? Where we can be in a situation where we're constantly rotating the signing keys for Hydra, and every builder actually signs the builds that they're doing, and that I can say, yes, this Nginx was signed on this Hetzner machine 2 days ago, and that I can if it gets compromised, or we do get like an email saying, yeah, this Nginx release was it's maliciously published, that we can revoke it and these kind of things. So we can learn things from other communities, and they're ahead of us in certain ways. For example, how they handle key material and like publishing, we are behind. And I really want to start flock together and see if we can integrate this into like NixOS Infra. This is also why I joined the Infra team, because I have some interest in this.
And I think there's also often a communication issue, because when you talk to security people, there's like terms that they know, like they're talking about SBOMs, about bills of materials and things like that, and they want to like keep track of vulnerabilities related to those bills of material and so on. And here we are doing kind of a different thing. And then you could, as a Nix person, you could say, well, we don't have a, we don't like, we almost don't care that much about producing a bill of materials because we would hope that this falls out of the process as those signatures or as that data we put on Sigstore or wherever we're gonna.
It's like
put
inherent
it, right?
properties of the system instead of something that you have to work to produce.
Yeah.
And that people find that, for sure. Yeah.
And I also don't know how, like, as soon as you, like, we have some projects in the Nix ecosystem to produce S-bombs, right? But then when people then want to use them, like the S-bombs produced in different ways tend to look a bit different, and then can you do something with them actually, right? Do you actually find corresponding vulnerabilities based on these S-bombs? I don't have that much experience with that. Like, Arian, I think you...
Yeah, it's difficult. Like when I go to my InfoSec team and I give them like an S-bomb that has 100,000 components in it, they said, yeah, we want an S-bomb of the build time dependencies. And they're like, why is Bash a build time dependency? I said, well, because we bootstrap Bash to bootstrap GCC to bootstrap this. These are all build time dependencies, right? In theory, but they're like, yeah, I just want to know how our software was built. I was like, well, that is how our software is built. You know? I'm just very honest to you, and everybody else is not being honest to you. But that's not what they want to. Yeah. So this kind of trying to explain these things to people that are used to get like a 3-page document with this is the software that we use, and I gave them a 200,000-page document with the software that we use, and they're like, why are you using so much more software than the other team? Like,
but
no.
they want compliance, not your 2000.
Exactly. Yes.
No, but still, even if people want compliance, we can have a good thing, right? That's,
yes.
And we can build tooling in order to enable people to have really good security tooling. I think it's really an opportunity for Nix to like grow into this role and help address very pressing problems that a lot of organizations have.
And this is also why I'm excited about like the Nix packages security tracker, right? Like that's also a thing that's a lot of people ask me, like, why don't you have that? Why aren't you not publishing which vulnerabilities were solved? How do I know? And like, we're getting there slowly. And I think we're gonna get there in a better way than other ecosystems, hopefully. Yeah.
So that was the Nix packages security tracker. Are there any other projects that we know of in this area?
Well, there's some things, like ahead of this panel, I made a discourse post. It's very confusing. I made a discourse post gathering some input, and a lot of the questions were around, well, how does Nix relate to this thing in the ecosystem or that thing in the ecosystem? We could maybe like talk about these things a bit. I don't know.
There is also a big effort we should mention that is ongoing, is to replace the bootstrap phase of Nix package. It's also related to software supply chain security. So essentially, when you build a package in Nix, you have to trust the compiler. No, because it was built from source, but what was it built from source from? And at some point, you have to trust something. And there was a big effort that has been ongoing in the Nix community to make this thing that you have to trust at the beginning as little as possible, essentially getting inspiration from the Geeks project that has made their bootstrap seed, so the thing that you need, the binary that you need to trust that is at the beginning of everything, a few kilobytes, I think, or a few bytes even.
This reminds me of something as well, related to supply chain security. In my opinion, Nix code is quite nice to audit. Because like, okay, in general not, because people can do crazy things, but if you look at building a Python package, you can look at the package description of some Python package or Rust package or whatever, and you can know what the ingredients are, right? And this is also something that's really cool about Nix. Since we build in a sandbox, we can give people a description of, oh yeah, this is you depend on this, and we know that this list is exhaustive. other people don't know that because they don't put their builds in sandboxes. And so if your Android project just fetches something somewhere from the network as part of some Gradle dependency that's not tracked in their log file, well, it can just do that and it just happens and you don't know about it. And you can work on reproducibility, like you can try to track the reproducibility of that thing, but you don't know that there's some thing that factors into it that you're not aware of, right?
So Nix sounds like it has many things in place, and if we get this right, then it would be another, or maybe even primary attractor, primary benefit that Nix could offer the software world.
For sure, yeah. I feel like if we put some effort into this, like, I think there was also a talk about the CRA earlier. I didn't attend it, but I assume my message would be like, I think Nix is uniquely positioned to answer a lot of like really hard compliance issues that large companies have, and that kind of makes Nix cool for enterprise instead of, you know, like it's boring, it works, it does the thing, and it's the obvious choice if you care about these things.
Yeah.
And the thing is, even if you don't care about these things, laws are catching up, and in the US you have to produce SBOMs about your software, and now with the CRA it's the same in the EU. Like, you're gonna have to have to start doing this as a company.
And also, like, you can take several angles at this, right? And I'm going to try a crazy one because you went with the corporate one. And I don't know if it is crazy, but like, what if AI takes over? Hypothetically, right? And there's like a lot of intelligent systems producing code. If that kind of works out, right? Maybe hacking systems becomes easier. And I think it's in that scenario where you care about the security of systems that are essential for like things functioning, like society functioning, it would be good if they were based on solid principles and not on like chasing after things, right? Yeah.
Is there anything else that should be mentioned?
Let me think.
There's like one person asked online ahead of time what they're supposed to do when they review a pull request. I think it's an interesting question. Maybe we can tackle that one.
Yeah, like there's the problem of like pre-merge CI versus Hydra, right? We cannot just build PRs and cache the results, because then people can poison the cache in funny ways. So it's like, how do you make sure that a pull request does the thing? And that's like, review that the fixed output derivations are the correct ones, and that you can reproduce fetching them, right? And that it builds. But also, like, is this a project that's like worth maintaining, right? And is it trustworthy? But these are human decisions. They're not technical ones. I cannot say this project is trustworthy or not. And this is where we're now talking about all these technical solutions, but it's also very much a human problem, right? Who do you want to give the privilege of being able to merge things or propose things, and how do you make, like, do we want to be the biggest package set in the world? That was our explicit goal at some point. We're just going to package the world. But is that sustainable or not? Like, this is the human side. We're all humans, and we see each other and we trust each other. But
especially when you see, for example, the XZ backdoor, where one guy invested years of his life to penetrate a project, gain the trust of the other maintainer, and step by step put a backdoor in a very well-used project. You see that there is also social and human aspect in security, and that's when we have 200 or maybe more now committers in Nix package, those problems tend to become much more complicated. And I don't know, like, for me, like, we don't really have any way to efficiently protect ourselves against this kind of stuff.
Is there a central point of discussion, a place where we get together and discuss supply chain security?
Now and here? No, I don't know. No, not really.
Like one thing that I like, it's not that active right now, but there's a matrix channel for salsa, right? That was a
there's the salsa matrix channel, and I'm supposed to know what the salsa acronym stands for, but I just forgot.
Okay.
But it's some standards to talk about supply chain security.
Supply chain security level standard level supply.
Yeah.
It's levels of supply chain security.
Yes.
It's basically meant to, and it's really good at that. If you don't have anything to do with supply chain security, regardless of using Nix or not, it helps you. Okay, what are my first steps improving this situation, and then what are my second and third steps, and so on. And so it does a really good job of like being a specification that people who are supposed to apply it like understand. And that's great. There's also guac, which is, I think they just liked it. Oh, there's salsa, and then there's guac for like guacamole, I guess. So, and they kind of go together, I think, to some degree.
They do.
In cooking, for sure.
Are there areas of this vision that are not being worked on?
Yes, there are lots. So it's like if we could, like my opinion would be there's too much to list, kind of, right? There's the PCR value pre-computing stuff that
this
you were
is
looking
like,
into, right?
Like there's work on like how do you make sure that the hardware that you use to build things is the hardware that you think it is, right? That's a step away from software. Like, is this the Hydra builder that is the Hydra builder, or did somebody swap it out? And there's lots of research there as well.
And you can then link that with the signatures again and have, okay, let's have a place in the signatures where you put that information so you can verify it later on, things like that.
Yep. If anyone wants to contribute, please get in touch.
Yep.
Yeah.
Any burning questions?
Yeah, that's it.
Silvan will hand the microphone. Silvan will choose the...
Testing. So how do you see the future of NixStore? Is it like an interplanetary file system or like a torrenting sort of everyone shares their local version and we do some sort of handshake and we share the building and the distribution?
I think one nice thing is once we have the content addressing down, we then are in a much better position to investigate the sort of alternative ways of moving bytes around, because the sort of specification of what it means to move the bytes correctly is now very decoupled from the exact communication and dissemination method. So yes, I hope we can kind of return to all those fun IPFS, IRO, other sort of amazing networking things, even NFS on a much firmer foundation once we get this foundational stuff in order.
So, great talk, thank you. As a user who's interested in this topic but doesn't have a lot of time to look into it, is there somewhere we can go to a central location and just kind of see updates on what's being done on this issue? Because like it's very interesting to hear about the Hydra thing, for example, or some of these other ideas, and it would be nice to just be able to follow and see occasionally, like once a month or every few weeks, or when something's tested, new ideas are being checked out, just to kind of follow along with the security developments?
No, but maybe we should.
We could just create a matrix channel, or what else could would be a good space?
Yeah, so no, but I think we should talk about whether we can have like, I don't know, a discourse topic or a matrix channel or whatever, where we can like do some kind of, I don't know, even if it's once every half a year, like what happened in supply chain security. I think it's a
good idea.
Good suggestion.
If that is created, it will be announced in the NixOS discourse announcement topic.
Yeah.
I had a quick question. Does anybody know what happened with Volnix and if there's anything in the same vein that's being developed?
I think SBOMNix is kind of the spiritual successor, and this Nix packages security tracker, which is like about to launch, where we're actually doing the triaging of which packages are vulnerable, which are not, in a centralized database with contributors, which will create a lot more high quality data. Volnix kind of overloaded you with like a bazillion false positives, and the Nix package security tracker, I would say, is like the biggest spiritual successor. But that's like almost ready to launch. We've been saying that for a long time, but I think it's actually almost ready to launch. So yeah.
Thank you to the panelists, to the audience.